sucking your child's pacifier clean may have benefits. For years, health officials have told parents not to share utensils with their babies or clean their pacifiers by putting them in their mouths, arguing that the practice spreads harmful germs between parent and child. But new research may turn that thinking on its head. Well, this is one face of the coin. This is the other face of the coin. Here you have Ariana Di Gregorio, a New Jersey mother who shares with us the experience of her son. And she says, don't be selfish. Don't kiss babies. It's not worth it. Why does she say that? Because she had a cold, but loved to kiss the child. And having a cold, she didn't know what the cold was caused by, and was caused by a very bad virus called respiratory syncytial virus. And the child developed a disease. Here is the child in the ICU with bronchiolitis, which is a very severe disease. So who is right? The mothers who, I will show you the results of that study, it's a beautiful study. The mothers who clean the pacifier with their mouth and then put it in the mouth of the child, or the mothers who sterilize the pacifier every time it falls on the floor. Well, I hope that at the very end of this talk, you will understand that there is another dimension to what we just heard from Ruth. That when we establish very early in life, even in utero, a very close relationship with our mother or with others that are in the environment that surrounds us, we not only share love, which is of course essential, we not only share company, but we fundamentally share another part of our being, which is the bacteria that inhabit in every cavity of our body, from our mouth to every other part of our intestine and so forth and so on, even our ears. And that is essential for health. And therefore, there is a fundamental biological dimension to being close, to establishing social relationships. And I'm not saying that the reason why we establish social relationships is to share our bugs, but also, think about it. The most intimate form of love is a kiss, and in a kiss, I can assure you, you share a significant part of your mouth microbiome. So why is that so important is the issue that I would like to talk about today. But the most fundamental rhythm, and that's why I'm showing this first, and I will show it also at the very end, the most fundamental biological rhythm is not circadian, that is during the day or even during the week. The most fundamental rhythm is the one between us, our mothers, and the mothers with the next child, and so forth and so on. It is a generational rhythm that is established in the way in which we relate to our mother, and then, in the case of a girl, that girl when she becomes a mother. We'll get that again to the very end. Often, the way we think about things in science has to do with the way everything started. As I will show you in a moment, the same thing is true for the bacteria that inhabit our intestine. A major determinant of that is how it starts. The major determinant of the way we have understood for more than 100 years bacteria has to do with the way in which their role, or one of their roles, was discovered. And the discoverers were, of course, Koch and Pasteur. We owe to these two gentlemen so much. They made one of the most important discoveries in the history of humanity, which is that bacteria causes terrible diseases. And I've also put here Chamberlain, who was a student of Pasteur, who discovered viruses. This is a fundamental discovery. Hundreds of children died during the first year of life. 1,000, millions, hundreds of millions because of infections. And the fact that we discovered the role of infections was a fundamental discovery in the history of mankind. But it was marked by the idea that bacteria are bad. That is where it started, and that's what it marked, how it was marked. And this gentleman here, Metchnikoff, who was also a student of Pasteur, summarized it very nicely in this book called The Nature of Man. And he discovered something that is very important. He discovered that the intestine was absolutely full of bacteria. That number is much less than the real number of bacteria for reasons that I will explain to you in a moment. But that was a very important discovery. He discovered that they were there. But for him, as he says here, they constitute a third of the human excreta. It is very varied. But in the end, he concludes, he refutes the theory of those that attribute any great functional importance to the intestinal flora. The idea was, why on earth do we have all these bacteria? They may not do anything bad for us while we have them, but in the end, they're bacteria. They're part of that bad part that causes all these illnesses. In fact, that approach to bacteria had, as I said a moment ago, very important positive consequences for humankind, because, of course, among bacteria and also among viruses, there is a small proportion that cause terrible diseases. And the fact that we discovered them, and 30 years later we discovered antibiotics, and 10 years later we discovered vaccines, meant that between 1950 and 2000, there was a dramatic decrease in all infectious diseases practically. And that is becoming also true in the developing world today. And that allowed literally billions of people to survive. And it's one of the reasons why we have some of the problems we have today with the large population we have in the world that needs to be fed. Great results. That took people to take it to the extreme. This is one of the great scientists of the 20th century who in a foundation, a Civil Foundation Symposium, kind of a think tank, said, why could we not make it a goal of ours to live in a world free of microbes? Which could be the dangers? And of course, he was a Nobel Prize winner, and a lot of people listened to Nobel Prize winners, and that is an idea that started to gain force. Perhaps we could get rid of all the bacteria and therefore eliminate all illnesses. And in fact, I received this in my house, telling me how horrible my house is. Because just 90% more dust is found on carpets than on floorboards. 50% of dogs and cats carry bacteria that causes food poisoning. I mean, 200 times more fecal bacteria on the average cutting board than on a toilet seat. This has been the attitude. The cleaner we are, the better it is. Sterilizing the pacifier of our children. And in fact, creating a situation of isolation would be the ideal during the first months of life for this kind of thinking. Because there are perils out there. Of course there are perils. All of these. My way of thinking changed radically when we did this study. And this was a study we published 20 years ago that really completely changed the way I thought about all this problem. Here you see, and we'll explain it very briefly, the results of a longitudinal study that we have been conducting in Tucson, where I live, for the last 40 years. And these were the first 13 years of life of the children that we have been following from birth, starting in 1980, who now very soon will become 40-year-olds. But at the time, we had completed the follow-up up to the age of 13. And here you see two lines. The open triangles are children who have 2 or more siblings in their home, older siblings, of course, or go to daycare. during the first year of life. You heard this morning that daycare has good results with respect to behavior. Well, you'll see here other results that are probably as important. The black triangles are children who do not have 2 or more siblings or who do not go to daycare. And of course, in early life, what you see here on the y-axis, on this side, is the number of illnesses due to viruses that these children had and that affected their lower airways, that affected their lungs. That's what we take care of when we take care of children with asthma. At the very beginning of life, these children had more of these illnesses. And that confirmed the prejudice that I have been talking to you about until now. I mean, these kids have more illnesses early. What was expected, right? Well, but what was completely unexpected is what happened later. Because when we continued following them, the open triangles are the exposed children, the black triangles are the non-exposed children. It happened that the non-exposed children, the ones who didn't have older siblings and didn't go to daycare, were more likely to develop asthma symptoms during that time than those who were exposed. This was exactly the opposite to what I was expecting. And the most important results that I have ever obtained in my life are the ones that I never expected. And then I started thinking, looking at this paper published more or less at the same time, that what has been happening is that as infectious diseases decrease, immune diseases increase. Both those that are due to inappropriate responses to the environment, such as asthma, or those that are autoimmune diseases, such as multiple sclerosis, Crohn's disease, and so forth, type 1 diabetes. And at the time, Jean-François Bach, who published this article, said, well, we really don't know why this is happening. And so I participated in a think tank about this, trying to understand this to and fro that we were finding between infections and these diseases. And already in 1999, with a very good friend of mine, Patrick Holt, we proposed the idea that this could be due to the fact that these children in early life were exposed to bacteria. We didn't know, the word microbiome did not exist at the time. But somehow we said, what could it be that makes children that are exposed to other children have less asthma later in life? And our conclusion was there must be something that is changing the immune responses very early in life. And that something has to have to do with the intestinal flora, because that's where the most bacteria are. Things immediately after we wrote that, and immediately after Jean-François wrote that article in the New England Journal pointing to this decrease in infectious diseases and increase in immune diseases, a big change occurred in science, the Genomic Revolution. This is the way, through culture, in which practically the only way in which we could detect any bacteria. We had to know the bacteria and what it could be raised in. This is so-called Petri dish. You just put a little bit of a tissue there, and you put the right medium that they can eat, and that's how they grow. That's how we did it from Pasteur up to the 2000s, more or less. Therefore, almost you needed to know the bacteria to find the bacteria. But something extraordinary happened with the Genomic Revolution. I'm not at all intending for you to understand what is all there, just to tell you that the way that we do it now is that instead of culturing them, it has been discovered that each bacteria has a marker in its DNA that allows us to determine that it belongs to a different species. Each bacteria has DNA that is different from other species of bacteria. And therefore, we were able to discover thousands more species of bacteria suddenly. The world of bacteria went from 1 to 100, literally. Every day there is an article in microbiology journals showing new whole families of viruses, for example, or bacteria and so forth and so on, found in the most remote places. I heard with the same rapture that everybody else, Jill's talk this morning. I have a very good friend who has dedicated herself to show that as soon as humans enter caverns, in this case, caverns on the air, we have a cavern right by Tucson called the Karchner Cavern. She has studied the Karchner Cavern, and she has discovered that if you enter more than a certain number of people at a time to the caverns, the microbiome, the bacteria that live there, change completely. And therefore, today, only 20 people at the time can enter. Why? Because we breathe bacteria with every breath. This is what we discovered thanks to genomics, that there were many more bacteria than we ever thought they could exist. That the trillions that Metchikov have talked about are billions of trillions of bacteria, that there are 10 to 100 times more bacteria in your body than cells in your body. And most of them are in the intestine. And how do those bacteria grow in us? And here's where the mother and what surrounds us enter. They grow in us very, very slowly. You can see on the x-axis here below that even at birth, this is 0. There are already bacteria. This here is the diversity of the bacteria. There are already bacteria in meconium, which is the first stool produced by the child. Why? Because the mother is permissive. The mother allows these to enter towards the end of the pregnancy to start accustoming, to start making the child know the environment that it will enter into. Jill told us this morning, and I copied some of her strategies, and it's extraordinary because these same strategies is what the children use to get used to the outside environment, which is, I was thinking this morning, like for him or her, it's like entering a cavern, the outside world, from the very protected environment of the mother to this new cavern, in this case with light, contrary to the darkness. But she said that we need a toolbox of solutions for perceived risks, that we need to rehearse, that we need to have the tool, that we need to understand, that we need to face multiple threats. Same thing applies to the child. The child needs to get used to what is outside, and particularly the most important thing, needs to understand what is friend and what is foe. And that is a fundamental skill that needs to be learned in early life. But for that, you need to enter the cavern. You need to run the risk. There is no life without risk. And therefore, what happens is that slowly the environment during the first year of life, this is beautiful study done by Susan Lynch at the University of California, San Francisco, the child slowly gets seeded by the environment during the first year of life and needs to reach that maximum that you see there between 9 and 12 months. Everything that it will be determined about what bugs are going to be in your intestine is already determined by between 9 and 12 months. What is the importance of these bugs? Well, together with the Genomic Revolution helping us find all these bacteria, it also allowed us to understand one more thing, something extraordinary. We have another organ in our body that we didn't know about. And that organ is what we call the interface, the relation between the bacteria that are up there, all those little rounded objects, and the epithelium, we call it, those cells that are there, that are the cells of the intestine. And a relationship is established between both of them, of symbiosis, of mutual benefit. They live there, and we feed them with our food, and not only with our food, because sometimes they enter the interstitium and are fed by the cells, and they produce these products, we call them metabolites, that cross the epithelium. Sometimes we actively, our cells actively make them pass. Why? Because they're almost like another endocrine organ, like the thyroid. They produce these products that interact with our immune system, it doesn't matter what the names are, with our bones, with our cardiovascular system, and even with our brain. And these products can be, depending on the bacteria we have inside of us, could be good for us or bad for us. For example, Timao, that is mentioned there, is not very good for us because it increases the likelihood of having myocardial infarction if you have too much of it. Instead, these ones here, small chain fatty acids, are essential for one of the most important cells in the immune system to grow maturely, which is the cell that regulates the immune responses. That says, no, 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 that's too much, or no, 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 that's too little. That stimulates other cells of the immune system to react more or react less. If you don't have them trained, that's not very good for you. And what we have discovered, therefore, is that there is a large number of functions in the body that depend essentially on the bacteria that live on us. And Pat was asking me the other day, why did we choose to give so much importance to the bacteria? Why didn't we just, why aren't we sterile? We could have been, probably, but we chose to do it because in evolution, we found that all this was in our environment. And with respect to everything else, we have to find a balance. Either you find the balance, or if you're completely sterile, some very bad bug is going to invade you and you're going to die. In fact, there is a disease called diarrhea due to Clostridium difficile, which is due to the fact that after taking a lot of antibiotics, we wipe out the bacteria that are in our intestine, and here comes an invader, and now it cannot get diluted in the large number of other bacteria that make it impossible for Clostridium difficile to attack us. It is when there are less bacteria that it can attack us. Here I'm going back to the pacifier study. When I saw this, I was astonished. I mean, black pacifier sucked by the parent. Here, look at asthma. I mean, these kids have almost 10 times less asthma than if they boil the pacifier, right? Look at that. I mean, they have less eczema. They're less sensitized to allergens. What's going on? That the mouth of the child is completely different if the mother suctions the pacifier than if the mother does not. This is a way to represent, this is one child, each of these triangles, and of course the ones that did not suck are on the left and the ones that sucked are on the right. And think about this as a single point representing the whole microbiome, the whole number of bacteria that are present in the mouth of these children. I mean, there are two different dimensions of children. The mother has seeded the child. So that contact that you heard a moment ago with Ruth has another consequence. You seed with your bugs your child. And of course, you expose your child to a risk. But life does not exist without risk. But people objected to that study. They said, oh, no, 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 wait a minute. Mothers who suck their pacifier are kind of strange. They have to have something else. They have to have something else. There must be something confounding this. There must be another difference. And we were thinking about this. Of course, there are very good animal models to show that what was found with the mothers with the pacifier was really also valid in animal models. But people say, well, it's animal models. Humans are not like that. Yes, it's very interesting. But you need to show something more. And there came this study. It was a study that came from something completely serendipitous. Dr. Holbreich is an allergist, and his wife is a hematologist, and she had a clinic in this remote place where the Amish live, here on the left. And she was tired of going alone to these clinics that she did once a week, so she decided to invite Dr. Holbreich, who is an allergist, and say, why don't you do a clinic? And they went there, and of course, because they have genetic diseases, the clinic for hematology had a line of people coming to the clinic. And Dr. Holbreich read the newspaper all day long. And so one day, one of us, I think it was me, I don't remember, was giving a talk about this, and he came to us and said, I have something interesting for you. These people don't have asthma. I mean, because when I started seeing that nobody came, I talked to the elders, and they said, well, we accepted that you did this clinic, but really, we don't know very much what asthma is. And so, but we didn't want to make you feel bad, so. And so we say, Eureka, here is a group of people who live on top of the animals, because they live exactly the way, I don't know if anybody knows the details, but Amish came to the United States running away from religious persecution in the Alps. And here was a very good example of people heavily exposed to bacteria. Why? Because they live practically on top of the animals. And you can see that on the left side. But we said, well, which could be the control group? And fortunately, one of the researchers was working among the Hattrites and found out that the Hattrites came from the same persecution as the Amish, and have the same customs as the Amish, and have 8 children or more in the family, and live in collective farms, and are clean as you can't imagine, both, because they clean the homes and so forth. The mothers dedicate their day to the children and to cleaning, and having everybody clean the home, all the kids. But there was a fundamental difference, that the Amish lived on top of the cows every day, and the Hattrites had decided that that was not very good, and had separated themselves from the cows and have the cows in these factories. So, exposure, direct exposure to cows on the Amish, no exposure in the Hattrites. Far away, I mean miles away. 4 times more asthma among the Hattrites than among the Amish. Why? Because in spite of the fact that the Amish are spick-span clean, as are the Hattrites, you enter to their homes, and it's extraordinary. It's completely clean. The Amish homes, living as they do right by the barns, is a zoo. It's basically all types of bacteria you can imagine. They have 5,000 times more bacteria in their environment, in spite of the fact that they clean all day long. Why? Because it comes with the air. And therefore, the conclusion of these studies came from taking the dust from the Hattrite homes and the dust from the Amish homes, and doing now the same experiment with an animal model in mice. And lo and behold, the dust from the homes from the Amish completely blocks the allergic response in mice. Instead, that of the Hattrites doesn't do anything to the allergic response. There's something in the dust, and we're increasingly demonstrating that that something is the bacteria present in the dust that block that immune response. So my last slide. I think what has happened is that out of fear from the environment, out of fear of the environment, out of fear of an attack, the wolf is coming, we have changed our life in ways that have disrupted the coevolution that we have with the bacteria around us for the last millions of years. We have become much more sterile than we should be, but it is even worse because we have allowed the wrong bacteria often to inhabit the intestine of our children. I think the solution is to reestablish that balance. And the way to do it is completely parallel to everything you have heard about today, is socializing, is expressing directly the love we feel for each other. Of course, there are going to be risks. But in the same way that Jill prepares herself for entering the cavern, the children are prepared by the mother to enter the cavern. Evolution has prepared them. We have to base our lives not on fear, but on trust. Trust that our children will be able to overcome these situations. And if they are affected, like the child that had bronchiolitis, today we're developing new vaccines and new ways in which to prevent that the bad bacteria or the bad viruses can have the better of us. So I think that we don't need to go back to the farms. It's not necessary. What we need to do is what is common sense, what we have been hearing today all along. We need to socialize early our children. We need to surround them with love, and I can assure you that will do a lot, not only for their behavior, but also for their health. Thank you.